Well, good afternoon, everyone. Uh, I'm Raymond from Israel, and today we'll present a small book survey that is conducted applications of Vedic mathematics in high-speed system. I would like to thank IAVM for giving me the opportunity to present this work. This work includes also some slides that are that gives us the background of Vedic mathematics, but I think everyone over here is well familiar with the background in Vedic mathematics, so I will just jump over that afterwards. The agenda is the introduction, a bit about Vedic mathematics, McCall's quality factor model, the survey design. There are 10 designs that were surveyed. Its connection is association with the quality factors, conclusion, and further work. I will start with the introduction. Today, in this fast-growing world, we know that that we are obliged to have computers who are very, very fast, accurate, and the basic things that they do is multiplication, division, reciprocals, and other basic operations. They play a vital role in the field of digital signal processing, DSP, image processing, graphics, and henceforth. All these operations are implemented in software using hardware. So with the advancement of technology, computers need to get very, very fast, and there are all these new applications that need more processing speed than before. Therefore, the basic element in this of the system is the multiplier, and performance of the system is determined by the key component, that is the multiplier. It is also considered the slowest element in the system since it consumes more storage area, and therefore it has to be optimized in terms of speed and storage area, and therefore this issue is a critical one. We know that Vedic mathematics can be applied to many computations, and it is considered to be very, very effective as they are compared to conventional methods, and therefore many of the students from electronic and engineering students have done various projects till now of applying Vedic sutras to come out with multipliers, and they have been published since the last 10 years or more than that. I have taken some of them and I have made a survey of that and what each one of this work has given us. And then secondly, I have associated them with the quality factors. There are several quality factors models are available. I've chosen the McCall's quality software quality factors, and then the association with them, and drawn a few conclusions from them. As everyone knows, Vedic mathematics is a set of strategies to solve a range of mathematical problems. It includes 16 sutras, 13 sutras, and they can be applied in geometry, algebra, arithmetic, and henceforth. Now, here are the 16 sutras with its translation, and the 13 sub-sutras or sub-sutras. We'll talk a bit about the quality model, McCall's quality model, which includes three categories that is related to product transition, product revision, and product operation. The most important one, everything is important. The most important one is the product operation one. This model was applied since the last 20 years while developing the software. This is one of the things that are prepared during the setting the requirements for quality of softwares. This is the must document, since when you draw the requirements for a software, you can't incorporate all this 11 quality factors that are included over here, but they make a compromise, and what you can say is the importance. They are arranged according to the importance that the software should achieve in order to gain the maximum customer satisfaction. So this software quality categories, the three of them, the most important is the product operation factors. They deal with the requirements that directly affect the daily operation of the software. Then the product revision software deal with the requirements that directly apply the complete range of maintenance activities. And the transition factors, that the original software can be adapted to other environments or other interactions. Now this all of these categories, three of these categories are sub-factors. They are one second. All the quality factors that we talk about, product operation, are divided into 5 quality factors, and there are several sub-quality factors, as you can see. We'll go through them. The first one is correctness, the ability of the software to give an output, given an input to an extent that it meets the defined requirements. Reliability, it is the most important thing in software. It's the maximum allowed software failure rates. It's related to the entire system or to separate functions, units, as you call it. Efficiency, it deals with hardware resources needed to perform the functions of the software, and it should confirm the requirements. Integrity is the extent to which access of software data by unauthorized person can be controlled. Usability, the extent of which the program is easy to use and its tolerance level of other users, user errors. We'll move to the next category, that is the product revision. You have 3 quality factors over here. The first one is maintainability. The fourth require, locate and fix an error in an operational program. Flexibility, effort to modify the operational program. Testability, the effort required to test a program to ensure its performs its intended function. And the last one is the product revision. It includes also 3 quality factors: portability, reusability, and interoperability. Its portability is the effort required to transfer a program from one hardware configuration or one environment to another environment. Reusability is it deals with the use of software models originally designed for one project, and now it can be used for another project that is under development. And the last one focuses on interfaces with other software systems or other firmware. Here is the diagram that shows up the relationship between the quality modules and the factors and sub-factors. Now we will go through the most important 10 designs, multiplier design that is surveyed. 3 Four sutras from Veda were used for that. Most of them were vertically and crosswise, all from 9 and last from 10. Transpose and apply, and all the multipliers. The first one, multiplier designer, based on ancient Vedic mathematics, was written by Hani Durga Tiwari. She developed a multiplier for low power and high speed applications. It was based on the sutra vertically and crosswise, and she was able to give us a faster multiplier with low delay time, and the design area was very less. The language and tool that they used for that was Electra, FPGA. The second survey was high-speed, energy-efficient ALU, designed using Vedic multiplication techniques. It was published in IEEE in 2009. She also used the sutra vertically and crosswise, and she designed a high-speed multiplier that helps the coprocessor, which reduces the load. This optimized Vedic multiplier was efficient, having advantages like parallel generation of intermediate products. It was low delay in time and less design area, which is very important. The third one was Vedic Mathematics based multiply accumulator unit, which used the same sutra as before, where vertically and crosswise. They used the same, they found that, one second, I'll get it. Okay. This algorithm was implemented in VHDL. Their approach was compared with modified Booth-Wallace multiplier and with the high-speed Vedic multiplier. They found that that it was found to be this Vedic multiplier produced delay in time, reduced delay, and it was realized on silicon due to its regular and parallel structure. Another one was the design DSP operation using Vedic mathematics. They used also vertically and crosswise sutra. They proposed a designing DSP, that is the digital signal processing operations, using multiplication in this operation like convolution, correlation, and they implemented this operation on MATLAB. Their approach required less processing time in microseconds as compared to the inbuilt functions in MATLAB that were in milliseconds. So that was fantastic. Another one was the novel architecture for inverse mixed columns as AES using Vedic functions on FPGA. The tool was FPGA. So they identified that the need of high-speed cryptographic algorithm used in secure transactions. So in order to meet this requirement, they developed an architecture for performing mixed columns operations, and that is considered to be a major operation in advanced encryption standard method of cryptography. So they used the vertically and crosswise, and what they obtained was that 100% efficiency in area and 2 times increase in speed as compared to other implications like splitting approach and lookup table and other things. Another one was a new paradigm in fast BCD division using ancient Vedic mathematics sutras. They used the Nichiren Sutra out from 9 and the last from 10 and transpose and apply. They have not written which tool or languages they use for conducting this work. However, they showed that the execution time does not depend on the size of the dividend or the divisor, but the number of remainders. It exhibited remarkable results with respect to conventional division algorithm. The VLSI implementation was not tested in this work. Another work presented in IEEE in year 2013 was the FPGA implementation of high-speed 8-bit Vedic multiplier. They used the Nichiren Sutra, all from 9 and the last from 10. It was implemented and verified using FPGA, an ISC simulator. It exhibited propagation delay, an improvement of about 45% as compared to other like array multiplier, boot multiplier, and conventional Vedic multiplier that was implemented before. It has a wide range of applications like image processing, arithmetic algorithm unit, and VLSI, signal processing. Another one was a bit difficult one was the optimized reversible Vedic Mathematics multiplier for high speed and low power operation. It was implemented by Saligram, and they had aimed to enhance the performance of previous reversible logic designs. They showed that the design had it was efficient in delay time and other things, and it was effectively adopted in designing FFTS, that is the fast Fourier transform, filters, and other applications in DSP. Another one was the FPGA implementation using the sutra, all the multipliers. This design was more efficient and less and fast as compared to other multipliers, and the lookup tables that were used to require to implement the multipliers were also less when compared to other multipliers. The last one was the binary division algorithm and high-speed deconvolution algorithm based on VN. It used the Nichiren Sutra and transpose and apply sutra. It was implemented, coded in Verilog, synthesized and simulated using IC. They implemented this on optimized binary architecture for calculating the deconvolution. The simulation results showed that the delay time was very less. It was reduced by approximately 19% as we compare it to the conventional method. The application of Vedic division in this approach for deconvolution had delay time of about 31% less as compared to the conventional methods. Now, if we look at all these designs, they had more or less the same features that were presented. Their approach was that the processing time will be less, to reduce the design area and reduce the delay time and low power consumption. We were able to find that all these features were very much related to efficiency and performance. However, we have about 11 quality factors and we couldn't find relationship because all of them were very much aimed at reducing the design area, the power consumption, and not focusing on efficiency or reliability or other things that are also very important. We couldn't find anything. So our conclusions were the Vedic sutras that were implemented in this design for multiplication were basically for reducing the time computation, design area, and power consumption and complexity. They were found useful in different applications like image processing and computation of heavy calculations. The factors that were associated were efficiency and performance. There were no such things that the accuracy or completeness of the data was found. Further work, we would like to search for similar works where including verification and validation of completeness and accuracy of data computation, which is not less important, and focusing much on reliability, which is considered to be one of the most important quality factor. And that's all. Thanks for hello. Thanks for everyone for listening and for joining.